All right. Unit 1, test. First thing you need to pay attention to is page 2 of your notebook. Remember, this is your proficiency scale. This tells all the things that you need to know by the end of this unit. So you have all of your words up top, which you should already be experts on because of the Quizlet practice you've done and the Quizlet test you've taken. Remember, that is your first step with any unit, is learning the vocabulary. And then you have these things. You need to be able to describe the difference between matter and non-matter. You've got to know what is matter and what is not matter. And we'll look in a few minutes. In your notebook, they give you specific examples that you better know, okay? You can collect and analyze data to differentiate between a pure substance and a mixture. What does differentiate mean? To tell the difference. You got to be able to tell the difference between a pure substance and a mixture. You can describe the 4 states of matter. What are they?
Solid, gas, liquid, and plasma.
Solid, liquid, gas, and plasma. Absolutely. You can observe examples and explain how matter changes from one state to another. So by adding energy, which is usually in the form of heat, but not necessarily, which we call thermal energy. By adding energy, it causes the molecules to move differently. And we talked about the faster they move, the different phases they go through. And so you need to know that. I can model and explain the movement and arrangement of molecules during changes in states of matter. I can measure the mass of several volumes of a liquid and use the data collected to determine the density of a liquid. So you can determine density. Now, this is a lab that normally we would do, but we cannot do because of the COVID stuff. But you need to be able to measure density. What is the formula for density? Mass over volume. Density equals mass divided by volume. So if you know the mass and you know the volume, you can calculate the density. Also, if you know the density and you know the mass, you can figure out the volume. Or if you know the density and the volume, you can figure out the mass. You just need 2 out of the 3 in order to be able to figure that out. So you have to be able to do that math. I can collect and analyze the data taken in the laboratory to generate and explain a heating curve. You will not have any questions on heating curves, so you don't have to worry about that. I can explain how temperature is related to average kinetic energy. If you've read your notes, you know that kinetic energy is energy of movement, okay? And that temperature is how much kinetic energy any substance has. That's how much those atoms are moving. Okay. And I can provide evidence and explain what temperature measures. What did we just say temperature is? What did I just tell you temperature is?
Kinetic.
It's the kinetic energy. So what do you think temperature measures? The amount of kinetic energy. Yeah. See how easy this is? All right, next page. So matter can either, I got to scroll up here. What is matter? If you notice that very first section, matter is anything that has mass and takes up space. You have to know that. You have to know that definition. Okay? Anything that has mass and takes up space. I would circle it, mark it, whatever you need to in your notes. Notice the examples there. 1 and 2 examples of matter. And then example of things that are not matter. I would know both of those lists very well. And then composition of matter, that's where we first hear the word atoms. You need to highlight that word atoms in there and know that an atom is the smallest unit of matter that has all of the properties of a given element. An atom is the smallest unit of matter that has all of the properties of a given element. Not to be confused with cells, which we studied last year, which is the smallest unit of living things, right? Atoms are the smallest unit of matter. Now, matter can either be classified as a pure substance or a mixture. Again, if you look down here on letter F, there are lots of examples of elements that are pure substances, which means they are not mixtures. And there are also random examples like a bowl of M&Ms versus a bowl of M&Ms and pretzels and Cheez-Its, okay? Obviously, if you've got M&Ms, pretzels, and Cheez-Its, it's a mixture, right? If you have a bunch of M&Ms, it's not a mixture. If you have plain M&Ms and peanut M&Ms and caramel M&Ms and almond M&Ms, it's a mixture, right? Because it's not the same thing. All right. Next page. This lovely periodic table of elements. You need to know the difference between metals, nonmetals, and metalloids. Okay? You'll be given a list of items, and you will have to pick out the metal of the out of that list, or the non-metal out of that list. You have a highlighted periodic table that you created, and there's one here for you in your notes that tells you if an element is a metal, a non-metal, or a metalloid. That would be a great resource for a question like that, right? All right, next page. This is where you start seeing reference to these states of matter and how the atoms move and are spaced apart based on the amount of kinetic energy that it has. You need to know the difference between the four states of matter. You need to be able to look at a picture and tell which state of matter is referenced based on that picture. For instance, solids are going to be packed tightly together. Liquids are going to have a little bit of space between them, and gas is going to have a ton of space between them. You know, it's a plasma if it has positive and negative signs with it, because remember, in a plasma, things are moving so much that the electrons actually separate from the rest of the atom. So those pictures right there will be a great reference for you. Also, notice it gives examples of plasma in letter D right above those pictures. Lightning, stars, neon lights. Those are good examples to know where to find them. Next page. All right, this is where you're going to start with all of your changes in states of matter. Remember, I told you, think in terms of water, and a lot of this will be something you already know. For instance, when a liquid turns to a solid, what do we call that? Freezing. It's the freezing point, right? The temperature at which a liquid changes to a solid is the freezing point. Now, that temperature is different depending on what substance you're talking about. But if you think in terms of water and the words that we use to describe it, then that will help you with these science words, okay? When it turns from a solid to a liquid, it is melting point, right? When it turns from a liquid to a gas, it's the, from a liquid to a gas, boiling point. It's the boiling point, Cheyenne, right? Okay, when it turns from a gas to a liquid, it's condensation. Okay, remember that's the cold can out of the refrigerator demonstration. So sublimation is one of those crazy ones that skips. It goes straight from solid to gas. There's no liquid in between. So some of those tricky ones like sublimation and deposition, you may have to look up, and this is the page you will find them on. But for the most part, those are things that you should already know if you think in terms of how we talk about water. Next page. These next few pages are all of those physical properties. Okay. And they give examples of those physical properties. So these are things when you're looking at whether something is a physical property or a chemical property, these are the pages you will reference. Physical properties include things like temperature, state of matter, whether it's magnetic, whether it's a good conductor. Those crazy words like ductile and malleability, which just means you're able to shape those things into other things. Okay, ductile means you can shape them into a long wire. Malleable means you can pound it into a flat substance. Most of those things are metals that can do that, right? You also have simple things like color, smell, taste. Density, mass, and volume are all physical properties that you need to be familiar with. Remember, viscosity is something I expect you to know. Viscosity, does it pour quickly or does it pour slowly? Okay. If it has a high viscosity, a high resistance to flow, it pours slowly. So I love to go to breakfast buffets. I'm not a big breakfast person. I don't, y'all get excited when we have breakfast for lunch here at school. Not me. I don't love eggs and bacon and sausage and all that stuff. But I do like to go to breakfast buffets if I have to eat breakfast. But I don't like when they put the syrup on the buffet table because it gets hot. And what happens with syrup when it's hot? Huh? It gets kind of melty, which means it pours really fast, right? And if I'm going to eat pancakes, I want my syrup to pile up on my pancake. I don't want it to just run right off into the plate. So when you increase the temperature of syrup, you decrease the viscosity, which means it just runs everywhere and it won't pile up on your pancake, so you get lots of syrup with your pancake. All right, so that is physical properties. Slide 10, chemical properties. This little picture here is a great visual. So if it's flammable, that's a chemical property. Chemical stability, which means it chemically combines with other things. Don't worry about the coordination number. That is something we'll talk about later. Reactivity and chemical stability are just the opposites of each other. If you're chemically stable, that means that it does not react with other stuff. Reactivity is it does react with other stuff, okay? Heat of combustion. What is combustion? Explosion, yes. So what temperature does it explode at is a chemical property, okay? Also, if it is toxic or poisonous, that is a chemical property. What did we talk about oxidation yesterday? What's an example of oxidation? What did we talk about yesterday was an example of a chemical change?
Oh, when you cook an egg.
Okay, when you cook an egg, but that's not oxidation. What did you say? Fireworks is an example, but that's because of the combustion, the explosion, and the changing color. What? Fire is definitely, flammability is a chemical property, but that's not what we talked about, or not what I'm looking for in oxidation. Yes, it's when the chemicals change to make a whole new substance. And what new substance did we talk about? I mean, yes, that was an example, but that's not what I'm looking for oxidation. When something chemically combines with oxidation, what is it? It is rust. Thank you. Yes, it is rust. When the iron combines with the oxygen in the air, you get rust. Same thing with the Statue of Liberty is made out of copper. Okay, but does it look like a shiny copper penny? No, it looks like those gross old copper pennies that have green stuff growing on them, right? That green stuff is the oxidation. It's what it looks like when copper has a chemical reaction with the oxygen in the air. Okay, so that is oxidation. That's what that oxidation state refers to. And that is it, guys. Those are the things you need to be able to do and need to know for your test tomorrow. It will be a multiple choice test. Some of it will be a choose all that apply. And it's an all or none. If you get them all, you get the question right. If you don't get them all, you don't get the question right. Okay? Use your notes. Use the video links in your notebooks and on your assignments throughout the week. It's not going to be something for the most part that you can Google the answer to. There might be one or two questions that Google will help you, but you've got to know your notes, know where to find the information, and know what that information means.